Okay, guys, we're continuing on with packet 2.4, also known as Unit 2B. We did part 1 already the other day, so we're continuing on with part 2 here. This first part I should have actually thrown in with the symmetry on part 1, but anyway, here it is. So sometimes functions are described as even or odd. So even functions are symmetric with respect to the y-axis, and odd functions are symmetric with respect to the origin. So a note here, except for the function f of x equals 0, a function cannot be both even and odd. Okay, so in example 2a, we're going to determine whether this function f of x is even, odd, or neither. So again, as the notes say, to test it if it's even, we're going to test over the y-axis. We're also going to test if it's odd by testing the origin. And again, if a function cannot be both even and odd, we may come back to that. So let's set this up as, instead of f of x equals, we can use y equals. So we're going to test if it's symmetric with respect to the x-axis first. So we learned on part 1 that to test if it's symmetric in respect to the y-axis, we would need to change the x's to negative x. So I'm going to do that now. And now I'm going to simplify. Remember that if it will turn back into the original function, we would put a yes there. Unfortunately, we're going to get a no. We have odd numbered exponents here, so that means this will be changing the signs in front. So this will be negative 5x to the 7th. This will be plus 6x to the 3rd. And this will be plus 2x. So this does not turn into the original equation. Therefore, it is not symmetric in respect to the y-axis. So now we're going to test if it's odd. And to test if it's odd, we're going to test if it's symmetric in respect to the origin. So remember from part 1, to test if something is symmetric in respect to the origin, you must change both the y and the x's to negative. So again, instead of f of x, we're going to use y, but we do negative y equals. And then we're going to do 5 times negative x to the 7th minus 6 times negative x to the 3rd minus 2 times negative x. So bring down the negative y. And then after the equal sign, you're just kind of repeating what we did for the x-axis. Negative 5x to the 7th plus 6x to the 3rd plus 2x. Now, don't stop here. Notice it's a negative in front of the y. Remember, you do need to attempt to turn it back into the original problem. The original problem starts positive y equals, so our guy has to also be positive y equals. And in order to do that, it's like dividing everything by 1. In other words, we're just changing the signs of everything. So look what happened. It did turn it back into the original problem. So this function, this f of x, is an odd function. And what does that mean? That means if we were to graph it, it would be symmetric in respect to the origin if we were to rotate it. Okay, next one. Now we're going to determine whether this new f of x is even, odd, or neither. So again, I always like to make notes here. The even we're going to test with the y-axis. The odd we're going to test in respect to the origin. All right, so the y-axis first. So we change the x's to negatives. And I have even exponents here. So when you have the even exponents, that means it'll kind of remain status quo. It'll be the same as it was. So negative x to the 6th becomes positive x to the 6th. So we keep the 5 positive. This will stay negative x to the negative 3x to the 2nd. Again, negative x squared is positive, and then minus 7. So this guy actually does turn back into the original problem. So we would say that this function, f of x, is even. Now, we're not going to test out the origin. We don't have to. Because if you actually look up here, right here, a function cannot be both even and odd. So since this guy is even, it cannot be odd. So here, let's go down to 33. We're going to determine visually whether the function is even, odd, or neither. So number 33, that is symmetric in respect to the y-axis. Okay? So therefore, if it's symmetric in respect to the y-axis, it is going to be even. If it flips over the y-axis, it's even. 34 is actually the same thing. It's a mirror image over the y-axis, so that's also even. Number 35 is a bit confusing. If you actually rotate your screen or paper 180 degrees, you'll see that it does form the same image. Therefore, it's symmetric in respect to the origin. Therefore, that's called an odd function. Number 36, if you rotate it, your screen, it is actually, it'll look, bear with me here. If you rotate your screen 180 degrees, I'm trying to draw a curve here. It'll be this, which does not match the original. You have to be careful with closed and open circles. This also does not reflect over the y-axis. Therefore, this is neither. It's not even nor odd. Number 37, pretty much the same thing as 36. If you rotate your screen or paper 180 degrees, this would not be the same because of the open circle, closed circle. So this is another neither. It's not even nor odd. Now, if, this one's very tricky, number 38. It's definitely not over the y-axis. That's easy to see. However, what happens if you rotate it? Rotate your screen or paper right now. You can pause it and check. What'll happen is you'll have this, which does look like it could be the same thing. Nope, sorry, I drew that wrong. It would be like this, which it does look at first glance like it matches. However, look where it crosses. Down here, it crosses below the origin. Up here, it crosses above the origin. So therefore, this is not symmetric. So we're going to write neither. Okay, guys, that's part 2 of section 2.4. I'll have some work shortly for you. It'll probably have to be some kind of worksheet or something outside of this packet because I don't think this packet hits up any other odd, even, or neither. Nope, it does not. So Hang tight. Have a good day.